I'm glad that you
Why did you study for school?
I got it, President. I got it.
You understand?
All right.
No.
So
Okay.
Monday we're going to do. You guys are going to be chemists for a production company, and you guys are going to apply today's stuff. So get ready for tomorrow to do some engaging work.
Why would we do that? Monday?
Monday, sorry. So the most practical chapter, as far as it's used to reality and real life situations, is this chapter. Okay? When we said that everything is going to reach a state of equilibrium, every chemical reaction will reach a state of equilibrium, correct?
Yeah.
Okay? So, if you want to produce a chemical, right, if you were a production plant and you wanted to produce a certain chemical, you would want the equilibrium to lie as far to the right as possible. Why? More products, right? The purpose of a chemist in those big production plants and those big companies that produce, whether it's a chemical for medicinal purposes, talking about dealing with, a drug to overcome you name it medically, or if it's producing just, a product you eat or whatever, the goal of chemists is, how can I cause equilibrium to lie as far to the right as possible? And what we're going to talk about today is, there are certain things that we can do to make the equilibrium shift. Okay? And that's what the goal of today is. In fact, when I worked in the lab, that's what I did. I wanted to purify stuff, and so I had to come up with some techniques to hopefully get things to be purified, using a lot of this very same stuff I'm about to teach you. Okay? Le Chatelier's principle. Le Chatelier is just the guy who came up with this idea. It says it shows how equilibrium of a system will react to stress. Okay, let me ask you. When you guys are stressed, you guys just wallow in that stress. You just sit and just let that stress just get to you, right?
I just procrastinate do anything else.
What do you usually do when you're stressed?
Read books.
Why do you read books?
To get my mind off of what I need.
So you read books so that you can forget the stress.
Basically.
Okay? What do you guys do?
Sleep. Video games.
Video games. Most of the time when you're stressed, you do something that helps alleviate that stress, right?
Killing people.
On
Wow.
video games.
That's on YouTube.
Alright, Maddie, let's go.
No one say her last
Just
name.
start the
We don't want her to get the top.
Sorry, future class.
Let's go. Let's go.
So believe it or not, chemical reactions act the same way. If we apply a stress to a chemical reaction, it will shift its equilibrium to undo the stress.
I hear you.
Okay? It's just like us. When I'm stressed, I do something that helps undo the stress, or make me not feel as stressed. Okay? It's the same thing for if a chemical reaction is stressed. It will shift in a way that will help reduce or undo that stress. So, that is what Le Chatelier's principle is. When a reverse reaction is stressed, it will proceed in a direction that relieves the stress. So let's talk about a few of the stresses. I can stress a reaction by changing concentration. I can stress a reaction by changing the pressure, increasing or decreasing the pressure. I can increase or decrease the temperature that causes the stress on the reaction, and I can add a catalyst. First one. I'm just going to use this generic example. Okay. It says the reaction will shift away from the side from which a substance is added to relieve the stress of more of that substance. I know that's really wordy, but let me kind of break it down a little bit easier for you. I have reached equilibrium. So all of these things are saying I'm at equilibrium, I'm applying the stress, and it's going to shift. Okay, left or right to go back to equilibrium. Okay, so for example, let's say I had a certain starting point and this eventually reached equilibrium. If, when it's at equilibrium, I add more of this. Okay, what is the stress?
There's more concentration.
What is the concentration, or what is the stress in this context? What did I do to it? I added a reactant. Okay? If that is the stress, and I want to undo that stress, what do you think the chemical reaction is going to do? Yes, because that'll do what to the reactant that I added?
But I thought the concentration didn't affect the equilibrium, it was just the rates.
Well,
Oh,
if I add, no, it's actually built upon last chapter. Okay? Collision theory. If I add more reactants, don't I have more reactants to collide with each other? Won't that increase the rate of the forward reaction
Yeah.
without changing the rate of the reverse reaction? So if now the forward reaction is faster than the reverse reaction, they're not at equilibrium, it will shift to produce more products so that it balances out again and reaches equilibrium once more. Okay? So if I add a reactant, it's going to make the forward reaction faster. So we'll start producing more products, and as the products start to go up, the reverse reaction starts to get faster, and eventually they reach what again? Equilibrium.
now I will.
Okay? So that is the conceptual why behind it shifts to the right. Now here's the easier way to remember it. When you add something, it shifts away. I hesitate to give you that because if you understand it conceptually, you won't have to memorize something silly like that. And it's far more valuable to understand what's going on. What is the stress? I added this. That's the stress. It wants to undo the stress. The way to undo the stress is to react it. Producing what? Products. Shifting which direction? Does that make sense? What happens if I add a product?
Then it's going to shift to the left.
It's going to shift to the left because I'm stressing the product. The way to undo that stress would be to react that product, right? Causing it to shift left and reach equilibrium.
Wait, why would you want to add that one?
You really wouldn't normally. Unless you wanted the reverse reaction to be favorable. But from a chemist standpoint, in a lab, if I want to produce more product, there's really two things I could do. Add more reactants or remove products.
Oh.
I'm balancing what?
Yeah.
No, I mean the rate at which it reacts is dependent upon that equation, but I can add as much or remove as much as I want. It still will react in the same ratio. That's why your KEQ ends up being the same. So if I continue to add reactants, you're probably thinking, well, isn't that going to change the equilibrium constant? No, because it just shifts, it takes this reactants and converts it into products to the same ratio it was at the beginning.
Like if you just added more 2H2 and no more O2.
Well, yeah, you probably want to add. Well, it depends on how much of each you had. If you didn't have any more O2, then yeah, it wouldn't do
Limit.
anything.
So it's
Yes.
just like making a bigger batch of something.
Of-
and then exchanging it.
Blah.
Kind of, yeah. I mean, you're not actually going to change the equilibrium constant, but you're causing it to react more. Let me give you another example. A lot of times what a chemical plant will do is they'll purge, is what it's called. What they mean is they'll start taking out the products as the reaction's happening. Okay? So what is the stress?
Concentration again?
Yeah, still concentration, but I'm removing. Does that make sense? I'm removing it. The stress is removal. So it wants to undo the stress by producing more of it. Think of this conceptually though. here's the conceptual part. If I'm removing this, do I have less products that can collide and go that way?
Yeah.
So I'm really slowing down the rate of the reverse reaction.
So it's still gonna shift.
It's still going to shift right, because if this becomes slower, and this didn't change, which one's faster? The forward reaction, right? Does that make sense? So there's two things. If you add a reactant, okay, it's going to shift to the right. If you add a product, it's going to shift to the left based on the collision theory that we talked about. If you remove a product, it's going to shift to the right. If you remove a reactant, it's going to shift to the left. Again, based on the collision theory. Remove a reactant.
Oh, yeah.
Let's look at this from removing a reactant. I start pulling out reactants. Now you probably wouldn't want to do this because usually the purpose is to produce products, right? But if I remove reactants, okay, of taking these away, are they going to collide as much? If they aren't going to collide as much, are they going to react as fast? That's going to slow the rate of the forward down. So which one's now faster, forward or reverse? The reverse is faster.
But is it ever like favorable, like the product doesn't want to go back to being reactive, just because it's like more balanced or something, like more stable in the
It will always reach a state of equilibrium. Yep. It will always proceed towards a state of equilibrium, because equilibrium, that equilibrium point is where the breaking point of being spontaneous or not is. Right? So if the forward reaction is spontaneous, it's going to proceed until you reach equilibrium. If the reverse reaction is spontaneous, it's going to proceed until you reach equilibrium. So in the end, no matter what, a reaction is going to reach equilibrium. Where it lies, whether it's product favored or reactant favored, that does depend on the nature of things. And exothermic versus endothermic, entropy, all those things we talked about before, kinetics, rates, all that stuff play a part in that. Absolutely. Okay? So, if you want the dumbed down version, this is the dumbed down version. Now, this will get the basic questions answered on a test, but will this answer the questions why? And do you think the test is going to be a lot of why and not just, hey, which way will it shift?
Yeah. Conceptual.
Okay? So, if I add a reactant, which way will it shift?
To the right.
To the right or away? If I remove a reactant, which way will it shift? To the left or toward. That makes sense. That's the quick way of figuring out the shift. However, your test is probably going to have some of those questions, but also have why questions. Why did it shift to the right? The reason why it shifted to the right is because I added more reactants, making them collide more, increasing the forward rate. That's why it shifts to the right. If I remove reactants, I have less things to collide, slowing down the forward reaction, making the reverse faster, shifting to the left. Now, will they eventually always balance back out? Absolutely. So when we shift it, it causes it to shift one way or the other, but it will always come back to equilibrium. Right? And that's what the rest of this stuff says. Let me see. Alright. This is important to note. When I add a reactant or remove a reactant or add a product or remove a product, it doesn't change the constant. Because it will shift back to equilibrium and it will maintain the same ratio. If I have a bunch of this, doesn't it produce more products, eliminating this, making that go up, and so it ends up being the same ratio in the end? the KEQ, or the equilibrium constant, when you add a concentration stress to it, it will always give you the same constant in the end. Okay? We're going to end here. We'll finish this lesson tomorrow. No, Monday.
No homework?
No homework.
This is a great.
Wait. You guys can take a shot.
I'm sorry I'm not loving you guys, but it's heavily
So
conceptual.
bad.
Okay? So I want you guys to make sure that you guys engage. If you're struggling with any of this stuff, to come in and get help. Because it is hefty conceptual stuff.
I wasn't sure, I didn't remember what he said about this, so I just like summed it up, right?
Elections, not stuff.
I don't know. I said I thought it was me when the guy got shot and that while we just saw the thing. That was me. Wait, no, 67.
6 or
He was on medication.
But what is tribulation?
It's a good thing game.
Wait, just said it was like.
What matters?
General words, I mean trials.
That'd be so smart. She was having seizures, like she was shaking.
106 degrees.
Well, she just texted me.
I'm hungry, my dad.
Well,
Yeah, well, we did.
she might be.
103.
Okay. Okay.
I
You
thought
can say it at
106.
106.
I was about to say 106. That's
Oh, yeah.
There's no way.
Wow. Lots of people get sick.
I've been sick like 5 times. The 12th. Friday.
Okay.
Sorry.
Go this way.
We should put a rush record, man.
Question mark?
Moving
It's
pictures.
review day.
It's got.
Lesson